Dear student, good morning to all of you. Today we are going to discuss some numerical problem on interference. In interference, we already discussed the three topics: interference in parallel thin film, interference in West-Shape film, interference in Newton's ring. Dear student, frequently asked question in AQTU semester examination. First of all, the important question: what are the coherent sources? Essential condition for observing the phenomena of interference of light. Dear student, in when we discuss the interference, we already discussed two sources of light are said to be coherent if their initial path difference is constant. Dear student, these are the condition of the coherent sources. Next, to obtaining the interference pattern. How we obtain the interference pattern? First one is condition of sustained interference is essential required for obtaining the interference. Next, observing the fringes is important part of interference pattern. Good contrast maxima and minima are responsible for the interference pattern. Classification of these 3 points, we can obtain the interference. Dear student, next we are going to discuss what are the condition of sustained interference, how we achieve. For achieving this, two source of light should be coherent, means their initial path difference must be constant. Dear student, two sources must emit continuous wave of same wavelength. These two are responsible for producing the sustained interference. Next, for observing the fringes, two source should be small, means separation of two source is very small. The distance between two source and screen are very large. Background should be large. With the help of these three conditions, we observe the fringes. Dear students, good contrast between maxima and minima is observed if we take source of light is monochromatic and amplitude of interference wave should be equal. Then we get contrast maxima and minima. This all about to achieving the interference pattern. Dear student, next we are going to solve some numerical problem. Dear student, here is the numerical problem for Newton's ring. Question is, Newton's observed in the interference light with the wavelength 6000 Armstrong if the diameter of 10th dark ring is 0.5. Find the radius of curvature and thickness of the air film. How we calculate the diameter of nth ring? We know the formula: dn square is equal to 4n lambda r. R is equal to dn square 4n lambda. We substitute the value of dn, n, lambda and r. Dear student, dn is 0.5 square, 4, and n is given here 10, lambda is 6000, 10 to the power minus 8. We get R is 106. Dear student, R is 106 means radius of curvature of the lens. When R is large, then their deviation is minimum. We know it. Next, we are going to calculate the thickness of the film. How we calculate the thickness of the film? We know twice T is equal to dn square by 4r. T is equal to dn square by 8r. Here 0.5, 8 multiplied by r, 106. We get 3 into 10 to the power minus 4 centimeters. The thickness of the film. Dear student, next question is, two plane glass surface or contact one edge are separated at the opposite angle, edge by the thin wire. If 20 interference fringes are observed between them, in the sodium light of wavelength 5890 Armstrong of normal incidence, find the diameter of the wire. How we calculate the diameter of the wire? Dear student, we know T is the thickness, L is the length of the wedge. Here T is the thickness, L is the wedge length, theta is the angle between them. Dear student, we know from this diagram theta is equal to T by L. We know fringe width. How we calculate? Beta is equal to lambda by 2 theta. We substitute the value of theta from here to here. For n fringes, we know lambda is equal to n beta. From here we get beta is equal to n lambda beta upon 2t. Beta and beta cancel. We get t is equal to lambda n by 2. Here lambda is given, n is given. We calculate the value of T, means thickness of the wire. We get 5.9 into 10 power minus 6 meter. Next we solve the problem. White light fall normally of the film of soapy water whose thickness 1.5 into 10 power minus 5 centimeter and refractive index 1.33. Which wavelength in the visible region reflect most strongly? Dear student, for solving it, we know condition of maxima. Twice mu t cos r is equal to twice n plus 1 lambda by 2. Here the value of n 0, 1, 2, 3. We know it. T is given 5 into 10 power minus 5. Mu is equal to 1.33. For normal incidence, theta is equal to 0. Then cos r is equal to 1. Dear student, what happened? Lambda is equal to twice mu t cos r twice n plus 1 from here. Here 4 mu is given 1.33. T is thickness 5 into 10 power minus 5. Cos r is cos 0 1. Here we get 1. Twice n plus 1. When we substitute the value of n is equal to 0, then we get 26.6 into 10 power minus 5 Armstrong. This wavelength is not strongly occur with the visible light. For next order n is equal to 1, then it becomes 8.8 into 10 power minus 5 centimeter. From n is equal to 2, 5.3 into 10 power minus 5 centimeter. From n is equal to 3, it becomes 3.8 into 10 power minus 5 centimeter. Dear student, we know 5.320 into 10 power minus 5 centimeter lie with the visible region. It means 5320 Armstrong wavelength of the light for n is equal to 1 is strongly occurs with the reflected wavelength of the light. Dear student, next we are going to solve the problem from interference. In interference pattern, amplitude of intensity variation is found 5% of the average intensity. Calculate the relative intensity. Dear student, 5% variation means if we suppose the average intensity is 100%, then maximum intensity is 105 and minimum intensity is 95. Then we get I max is equal to A1 plus A2 whole square upon I mean A1 minus A2 whole square. Maximum 105, minimum 95. A1 plus A2 whole square is equal to upon A1 minus A2 whole square 105 upon 95. We calculate the ratio between A1 and A2. We get A1 is equal to 40 A2. Then what happened, students? We know I1 upon I2 is equal to A1 square upon A2 square. Here we substitute the value of A1 and A2. We get 40 A2 square upon A2 square. A2 square is cancelled, then it becomes 1600 upon 1. It is the ratio of maximum and minimum intensity. Dear student, today we are discussing the problem related with the interference. Next day we discuss the problem related with the diffraction. Okay, best of luck.